What? You guys don't like the U tries? I love the U tries. I just want 3 boxes. Okay. All right, so let's talk about 3.8. Let's talk about the union and the intersection of sets. Okay, so first let's talk about this word called the union. All right, what do you think? I mean, if you had to take a guess, like, what is the union of a set? What do you think that means? Everything together. Does that mean everything total or the middle part? That's what everyone always says. Okay, so the union of a set, right? Is the definition for us. The union of two sets, of two or more sets, is the set that contains all the elements of the set. So it's basically the set that has all elements of the sets. It has all elements of the sets. It sounds kind of trivial, but the symbol for a union is this. So let's say I have set A and I have set B. Okay, the symbol that represents the union of sets is just a big giant U, right? A union B, and that stands for A union B. Some people, when they read this as the word or. Okay, so whatever is in A or B, that's what we mean by the union, A or B. So as a picture, so here's a picture. Let's say that this represents my universe, okay, my universal set of all the stuff inside that square. That's my universal set. Okay, this is going to represent set A, okay, and this is going to represent set B. Now most people think that the union of A or B is the stuff in the middle. That's not. That's the intersection. That's the next thing that we're going to learn. The union of A or B is actually everything that's either in A or everything that's either in B. So the the union of the two is everything that's colored in yellow for you here. So this is A union B. It's whatever's in A or in B. Okay? That's the set of all elements of all sets. That's what that means. That's what the union means. All right, let's talk about the intersection. The intersection of two or more sets is the set of elements common to every set. Okay, so I'll write that down. The set of elements that are common to every set. So it is the set of elements common to every set. And that's our definition for us. And the symbol for the intersection is this. If I have a set A and I have a set B and I want the intersection, then it is the upside down U. All right? And it kind of looks like what it says. It kind of looks like an and, right? A big capital A, like if you think of this as like a big capital A. So this means and. So whatever is in both A and B. So if I was going to have my picture over here, and this represents my universal set, here's A and here is B, here's set A over here, here's set B over there. Well, the definition says the set of elements that's common to every set. Well, in this particular case, I only have two sets. So the stuff that's common is just the stuff that's in between. Okay, that's the intersection of two sets, right? Is that what you were talking about before? Yeah, so the intersection of two sets is right in between there. So the stuff that we're talking about with pictorially, this is A and B, whatever is in both A and B. Notice that's different than what's in A or B for the union of two sets as stated above. Does that make sense so far? Okay, the other thing, the last part, the other word that we have to talk about in the same section here is called disjoint sets. And I used that vocab word the other day. Do you remember what it means? Just disjoint sets. If you had to take a guess, what do you think it would mean? You remember me saying it? Yes. Disjoint. Yes. Daniel, what do you think, buddy?
A set that is not the outer part.
Yeah. Okay. So it's the sets that have no elements in common, right? So no elements in common. So there's no symbol for it. But how would I draw two disjoint sets? So here's my universe, here's set A, and here is set B. So set A and B are disjoint because they have no elements in common. Does Does that make sense? That's what disjoint means. So it's not necessarily everything outside. It's sort of outside the respective set A and set B if they are nothing in common, okay? So in this case, A and B are disjoint sets because they have no elements in common. Okay, so here are the three sets the way that we have just defined them. Set X is going to be a natural number that's less than 19. Set Y is going to be all Y's that are an odd integer. And set Z is going to be any multiple of 6. Okay, so we're interested in a few things here. The first thing that we want to try and talk about is X and Z. Okay, so am I talking about the union or am I talking about the intersection? I'm talking about the intersection, right? X and Z. So I'm asking myself, what is in both? What is common? This means and. What is in set X that is also in set Z? Do we know?
18.
18 is one of them. Yep, give me another one. 12 is one of them. True, give me another one. 6. Are there any more? No, there are no more, right? Because if we think about what is in set X, we have 1, 2, 3, 4, 5, blah, 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 all the way up to what? 19. All the way up to 19. Oh, no, less than 19. Yeah, 18. Thank you very much. It's less than that. So I have all of these numbers here. That's the set of X, right? Think about what's in the set of Z. It's going to be what? 6, 12, 18. What's the next one? 24. What's the next one? 30. And then this just keeps going forever and ever, right? So what's in common to both of them, right? Well, we can clearly see that 6 would be there. 12 would be there. And 18 would be there. And that would be it. So this would be X intersect Z. Does that make sense? You guys on board? Yeah, okay. What about this one? I'm interested in this. Just different color. What about this? What is in X and Y? What's in both sets, X and Y? Can we write it out? Was 1, 1, 3, 5, 7, 9, 11, 13, 15, 17. Is that it? That's it. So that is what's in X and Y. So I have three sets defined for you. I have set A is going to have elements 2, 4, 6, 8. Set B is going to have elements 0, 2, 5, 7, and 8. And set C will have elements such that it's any odd whole number, such like 5, 11, so on and so forth, okay? Any odd whole number. Now, A, I'm interested in this. What is A intersect B? Go ahead, tell me what would it be?
2 and 8.
Only just 2 and 8. Yes. Does everyone agree that's only 2 and 8? That's what's in both? What's common to both? Only 2 and 8. Okay, let's do B. What would be in A and C? Nothing, right? There's nothing. How do we represent nothing? Brandon, how do you represent nothing? Yeah, what's that called, buddy? The null set or the empty set, right? There are no elements in common between set A and set C. Yes?
We don't put the null set thing in between brackets.
The book doesn't, but it's the set that contains nothing. If you want to do that, that's fine with me. Okay? Let's do example or part C here. What would be in C and B?
Well, in C and
Hmm?
B, 5,
Just 5 and 7. Very good. Just 5 and 7. Awesome. What would be, here's example D. What would be in A union B? What does that mean? A union B. What does that mean? What's the symbol A union B represent? That's in A or B. So it can be in A or it can be in B. So that's going to be a pretty decent sized set. So give me the first element. What would you write down? 0, then what? 2, then what? Yep. 5, yep. 6, yep. Yep. 8. Very good. That's what's A or B, right? Awesome.